Okay, so good day guys. For today's lesson, we're going to talk about switch security configuration. So for modules 11, at the end of this chapter, you're expected to implement port security to mitigate MAC address table attacks, explain how to configure DTP and native VLAN to mitigate VLAN attacks, and to mitigate DHCP attacks, you're expected to explain how to configure DHCP snooping and configure ARP inspection, and lastly, explain how to configure port fast and BPDU guard to mitigate STP attacks. So implement port security, as we all know, no, this is the layer 2, or the layer 2 attack are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common layer 2 solutions. So for example, all ports or interfaces should be secured before you deploy, yung mga switches natin to the production use. So how to do that? It's very simple, no? You just need to disable those unused ports. For example, you have a switch here which has 24 ports, and a router is connected to one port, and another switch is also connected to another port, and let's say your computer is connected on this port. So it means there are 21 ports, no, unused. So you need to disable them. Then how to do that? You just need to simply type shutdown command, no, and then if you want to reactivate them later, you just need to type in no shutdown command. So to configure a range of ports, use the interface range, no, so that you will not type in the command, no, one by one per port. So just simply type interface range, what is the type, then module, what is the first number up to last number, right, in the global configuration mode. Now, to mitigate MAC address table attacks, the simplest, and most effective method to prevent MAC address table overflow attack is to enable port security. So port security limits the number of valid MAC addresses allowed on a port, and then it allows administrator to manually configure MAC address for a port, or to permit the switch to dynamically learn and a limited number of MAC addresses. So again, as we all know, the switch is only capable of storing 100 up to 132,000 MAC addresses on its memory. So the attackers, or the threat actors, try to overflow, or overwhelm that MAC address table by flooding 8,000 MAC address per second, as we've discussed last meeting, doon sa ating chapter 10. Now, so by limiting the number of permitted MAC address on a port to 1, port security can be used to control unauthorized access to the network. It means only those authorized users, such as the administrator, now can access our network. So to do that, it's you just simply type interface F01, and then switch port security. Okay, as you can see, we have here switch port mode access, and then switch port port security. Okay, so port security is enabled with the switch port security interface configuration command. So notice on the example, the port security command was rejected. Why? So it is because the port security can only be configured on manually configured access ports or manually configured trunk ports. So by default, layer 2 switch ports are set to dynamic or auto, or the trunking on. So trunk port security is beyond the scope of this course. So enable port security, use the show port security interface. So once you type that, okay, so you can see on the show commands, or the result, we have here the port security is enabled, violation mode is shut down, and then what is the maximum MAC address. So in our example, it's 1. So if a device is connected to the port, the switch will automatically add the device MAC address as a secure MAC. So in this example, no device is connected to the port. Okay, as you can see, there's a 0 figure here. Now to enable that, so switch port security, and then question mark, we have here the different port security examples, or options. We have aging, we have the MAC address, maximum, and then the security violation. So those are the list of parameters that we can add or use when enabling port security on our switch. So let's first go to port security maximum. So we have here the maximum value is from 1 to 8,000 addresses. No. So for example, you just simply type switch port security maximum, and then let's say 500. It means the maximum MAC address, no, that can be saved on that table or on our switch is 500 only. So as you can see here, the maximum is 8192. So if you will not indicate, no, a value here, by default the switch port security will now use the value, no, the maximum value 8192. So okay, here the default port security value is 1. No, if you did not change that by typing that command. So the switch can be configured to learn about MAC addresses on a secure port in one of three ways. It could be manually configured. So as you can see here, switch port security MAC address, and then what is the MAC address? So it means, no, this is a manually configured. So the administrator manually configures a static MAC address, no, by using this command. Then dynamically learn when the switch port security command is entered, the current source MAC address for the device connected to the port is automatically secured but is not added to the running configuration. So pag nag-reboot yun, it means you need, or the device need to relearn the device MAC address. Again, it is not added to running configuration. It was not saved, no, on the running config. Okay? And then dynamically learn sticky, the administrator can enable the switch to dynamically learn then the MAC address and stick them to the running configuration. So to do that, you just simply type switch port security, MAC address, and then sticky. It means once the switch dynamically learned the MAC address of the device, even though when you rebooted the switch or the system or the device, still the configuration or the MAC address is learned, no, or saved on the MAC address table since you included or you typed the command sticky. So saving the running configuration will commit the dynamically learned MAC address to the NVRAM. So we have the limit and learn MAC address. So we have here an example. So switch port mode access, and then the security was enabled. Then maximum MAC address is 4, and then this is the MAC address. It means it is manually configured, and then it is dynamically learned, and then sticky yung in-apply, no? And then when you use show port security interfaces, so you can see it's enabled. So this is that's that one, and then the violation is shut down, and then we have the 4 maximum MAC addresses, and then total MAC address is 1 since it's sticky, manually configured. No, we have a value here. So port security aging, no, can be used to set the aging time for static and dynamic secure addresses. It means, no, the aging or use aging to remove secure MAC address on secured port without manually deleting the existing MAC address. It means they'll be automatically deleted based on the aging. No? We have here absolute. No, the secure address on the port are deleted after the specified aging time. For example, after 24 hours, after 36 hours, now those addresses will now automatically be deleted. Now we have inactivity, so that the secure address on the port are deleted if they are inactive for a specified time. So for example, they're not active or they did not log in for let's say 6 hours. Now it means you can now delete automatically that address, no, on our switch. So by typing switch port security aging, now if we want to use static, what is the time? Now type, it's either absolute or inactive. So port security aging, this is our example. So we have here port security aging type inactive. So it was set into 10 minutes. It means if the device is inactive for 10 minutes, that MAC address will be automatically deleted. Okay. So if the MAC address of the device attached to a port, no, differs from the list of secure addresses, then a port violation occurs and the port enters the error disable state. It means it's either you shut down that port you restrict that port or you protect that port. It means if they try to access that port again, no, it will not become available. So when shut down, by default, the port transition to the error disabled state immediately and turns off the port LED. So mamamatay yung ilaw. It means the status of the LED is naka-shut down, no? And then restrict, it will drop the packets, no, with the known source address until you remove a sufficient number of secure MAC. And when it's protect, this is the least secure of the security violation. Ita-drop niya lang yung packet ng unknown source MAC address until you remove the sufficient number of the MAC address. Wala ring system log na nasisend dito. Unlike here, there's a system log generated for auditing and monitoring purposes. So port security violation modes, ayan, we have port security violation, restrict, then makikita natin yung violation dito. Again, the default value is shutdown. So ports in error disabled state, when a port is shut down and placed in the error disabled state, no traffic is sent or received, no, on that port. So a series of port security related messages display on the console. Ayan. Makikita natin na when someone trying to connect on the port, makikita natin yung error logs. Ayan. Secure violation error detected on port. It means they're trying to access port 18 or fast Ethernet 018, putting a F8018 in disabled state. Ayan. Then makikita din natin dito. Line protocol on interface fast Ethernet 18 change state to down. So, sinut down niya. Okay. So, that's the sample of the error logs na nakikita natin sa console table. So, how to check, no, yung ating error disabled state? So, I just need to type in show interface. Then, makikita natin F8018 or F018 is down. And then, disabled or output emitted. Ayan, error disabled, output emitted. No? So, the administrator should determine what caused the security violation if there is an unauthorized device, no, connected to a secure port. So, para ma-enable yung port, kailangan mo munang i-type yung shutdown and then use the no shutdown command para mag-up ulit yung link nung port na yun. So, verify port security. You just need to type show port security and then makikita natin yung mga ports, list of ports, no, na active. And then makikita natin yung mga violation count if there's someone who's trying to access unauthorized access doon sa device natin using that specific port. Ano yung current address count and then ano yung current secure address, no, ng MAC addresses natin. Ayan. So, use the show port security interface. Ayan, ito ulit, no, yung kagaya ng pinapakita natin kanina. Ayan, naka-apply dito aging and then absolute. It means kapag hindi siya nag-login, no, doon sa binigay na specified time, madidelete na, no, yung ating source address or secure address doon sa port natin. So, to verify the MAC addresses are sticking to the configuration, use the show run command as shown in the example. Ayan, show run, begin interface. Again, we're looking at the fast Ethernet 019 interface. And makikita natin kung nakastick ba yung MAC address. So, kung wala kayong nakikitang ganito, it means hindi nag-stick yung MAC address na yung source MAC address na linalagay natin dun sa port. So, to display all secure MAC address that are manually configured or dynamically learned, you just simply type show port security address. Then makikita natin yung mga MAC address dito and kung saang VLAN sila, no, naka-assign. So, we have here, anong type? Dynamically learned. Ito naman, sticky. No? Ayan, F018, F019, yung mga ports natin. So, there's a packet tracer activity for that. I hope, no, you will answer those bago mag-final exam at masubmit, no, ng maayos. And you need to follow the instruction, no, para doon. Now, mitigate VLAN attacks. So, we have here the following for the mitigation ng ating mga VLAN attacks. So, VLAN attack review. So, meron tayong tinatawag na VLAN hopping. Diba? Yung threat actor Okay? Pupunta siya sa isang VLAN using 802.1q, no? Standard na pinag-usapan natin last meeting. And then kapag nagkaroon na siya na access dito, it means the threat actor can freely hop, no, from one VLAN to the other. So VLAN 10, VLAN 20, kahit saan niya pumuntang VLAN, pwede na siyang tumalon. So a VLAN hopping attack can be launched in one of three ways. It's either spoofing DTP messages from attacking host to cause the switch to enter trunking mode. Then from there, the attacker can send traffic tag with the target VLAN, and the switch then delivers the packets to the destination. Ito yung nag-strip na meron tayong double tagging. Ayan, di ba? Yung another type of VLAN hopping, yung double tagging na na-discuss last meeting. And yung introducing a rogue switch and enable trunking. No? The attacker can access all the VLANs on the victim switch from the rogue switch. Ayan. So how to mitigate those VLAN hopping attacks? First, we need to disable the DTP, no, yung auto trunking negotiation on non-trunking ports by using switch port mode access. So gagawin natin silang access muna lahat, no, instead of trunk. And then disable unused ports and put them in an unused VLAN. Let's say VLAN 50. It depends, no, kung saan VLAN mo gustong i-assign. Then manually enable trunk link on trunking port by using switch port trunk. Yung naka-trunk code lang dapat, yung naka-enable na trunk. And then set the native VLAN to a VLAN other than VLAN 1. No? As always, hindi natin pinapagamit yung VLAN 1 as the default VLAN kasi madaling i-hack. So mitigate DHCP attacks. No, DHCP or the goal of a DHCP starvation attack is to an attack tool such as Gobbler, and I discussed last meeting, to create a denial of service for connecting clients. So recall the DHCP starvation attacks can be effectively mitigated by using port security because Gobbler uses a unique source MAC address sa bawat DHCP request na sinesend niya. However, no, mitigating DHCP spoofing attack requires more protection. So Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. So, magre-render to ng port security and effectivity dahil yung MAC address natin is legitimate kasi nga ginagamit niya yung target, no, na MAC address. Yung kagaya na sinasabi ko sa inyo na kaya nating palitan yung MAC address ng computer natin for as long as the hardware supported that kind of feature, no. Kagaya nung ginawa ko dati, I can change my MAC address, no, kung kailan ko man gustuin. Ayan. For example, may nakita kang isang network, no, using a Kali Linux, and then naka-MAC filter yung network na yun. So you can just simply copy the MAC address of that host or a host connected to that network. And then pwede mo nang palitan yung iyong MAC address na kagayang-kagaya nun. Then you can have access to their network na. So DHCP spoofing attacks can be mitigated by DHCP snooping on trusted ports. Ayan. So what is a DHCP snooping? No? It filters DHCP messages and rate limits DHCP traffic on untrusted ports. So it divides under administrative control. It could be applied sa mga switches, routers, no? At saka mga servers. And then trusted interfaces, ayan, yung mga trunk links at yung mga server ports natin must be explicitly configured as trusted, no? And then devices outside the network and all access ports are generally treated as untrusted sources. So the DHCP table is built that includes the source MAC address of a device on an untrusted port and an IP address assigned by the DHCP server. Sabi ko nga, parang yung router natin is the DHCP server. So pag nag-connect ka sa Wi-Fi o kaya through your network, no, yan yung nagbibigay ng IP address sa atin. So, steps to implement DHCP snooping. So, we can use this one. Enable DHCP snooping by using the IP DHCP snooping global configuration command. On trusted ports, use the IP DHCP snooping trust. Ayan. And on untrusted interfaces, limit the number of DHCP discovery that can be received using IP DHCP snooping limit rate and then ilang packets per second yung gusto mong ilimit. Then enable the DHCP snooping by VLAN or by range of VLANs. So for example, meron ka multiple VLANs, no? 1 to 10, VLAN 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Para hindi isa-isa yung tinatype mo na VLAN, then you can use the VLAN range for that one. Ayan. So ito yung example natin. IP DHCP Snooping for enabling it. Then papasok ka sa interface. It means, no, yung trusted lang, yung interface na yon. And then ito yung range ng interface natin, no. Interface range from port 5 to port 24, no. Na-enable natin yung snooping, and then we limit the rate into 6 packets per second. And then yung VLAN, gumamit din tayo ng range from VLAN 5, VLAN 10, and VLAN 50 to 52. And pag sunod-sunod yung number, you can use dash, no. Pag isa-isa naman, hindi sequential yung number, separated by comma. So DHCP snooping configuration example we have here, show IP DHCP snooping, and makikita natin, no, naka-configure yung DHCP snooping on the following VLAN, yung ginawa natin kanina, no. And then yung DHCP snooping is operational on following VLANs. So wala naman tayong ginawa, na-configured natin kanina dun lang, no. So it is configured on the following interfaces. So anong interface yung kinonfigure natin kanina? We have the fast Ethernet 01, 05, 06. Ayan, unlimited yung rate. Dito, merong fix. 6 packets per second, no. So natatanda niyo sa previous ano natin. Ayan, command. So limit rate 6. It means 6 PPS, packets per second. So mitigate ARP attacks. Dynamic ARP inspections. In a typical ARP network attack, a threat actor can send unsolicited ARP replies, no, to the other host on the subnet. So for example, yung subnet mo is /24, it means there are 254 hosts available. Yan, sa BLSM pinag-aralan yan, di ba? Now, ang ginagawa ngayon ng ARP attack is nagsisend siya, no, ng mga ARP replies dun sa mga host natin sa loob ng subnet. And then the IP address of the default gateway, no, to prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. So, dynamic ARP inspection, o yung DAI, requires DHCP snooping and helps prevent ARP attacks. So, not relying on the invalid or gratuitous, no, ARP replies out to the other ports in the same VLAN, intercepting, no, yung mga ARP requests and replies sa mga untrusted ports. Again, no, sa isang command natin kanina, we show on how to make, no, yung ating port as a trusted port by typing the command kanina na IP, no, DHCP spoofing or snooping, and then trusted, and then verify each intercepted packet for a valid IP to MAC binding. Tapos ida-drop and ilalag yung mga ARP replies coming from invalid to prevent ARP poisoning. Ayan. Bakit dinadrop? Siyempre para hindi na makapasok sa network. So bakit nilalag? No, para dun sa monitoring and auditing purposes. So error disabling the interface is if the configured DAI number or ARP packet is exceeded. Ayan. So ito yung example ng implementation guidelines nung mitigation, no, of ARP spoofing and ARP poisoning. So enable DHCP snooping globally. Ayan, no, and then enable DHCP snooping on selected VLANs, enable DAI on selected VLANs as well, and configure trusted interface for DHCP snooping and ARP inspection. So, sabi dito, it is generally advisable to configure all access ports as untrusted. So, syempre, pag access port, ibig sabihin, sa labas yan, no? So, it's a good practice or advisable na untrusted lahat yung mga access ports. No? And then configure all uplink ports that are connected to other switches as trusted. Yung palabas sa network na yon, ito yung trusted. So dito yung security mo ngayon. Ito ngayon, mga access port lang yan, no? Para hindi mabutas ng actor o ng threat actor yung network mo. Kasi pag ito ginawa mong trusted, edi wala nang magagawang ano dito, mababypass na yung network natin. No? Kaya dapat untrusted para na-filter out yung ating mga pumapasok na traffic. So, to configure DAI, no? So, dun sa previous topology natin, S1 is connecting two users, no, on VLAN 10. Ito, yung PCA at saka yung attacker, no? So, ang gagawin natin ngayon, we will apply DHCP Snooping on VLAN 10 and then IPR inspection on VLAN 10. Tapos, gagawin mo, interface FA024. Sino yun? Ito, yung 24. Ito yung i-configure mo ng trusted. DHCP Snooping Trust and ARP Inspection Trust. So, dito, hindi mo sila gagawing trust. Untrusted dapat. Ayan. So, I can configure to check both destination or source MAC address. So, destination MAC checks the destination MAC address in the Ethernet header against the target MAC address in ARP body. So, yung source MAC, ito yung nag-send ng data or ng message. Then, kina-counter check lang yun against the header dun sa sender MAC address dun sa ARP body. And then, syempre, yung IP address, it checks the ARP body for invalid and unexpected IP address, including yung ating 000.000 and yung 255.255.255. Yung mga lahat ng multicast addresses. Ayan, chine-check ng ating ARP dun sa body natin by using DAI. So, ayan. So, the IP ARP inspection validate ano yung source MAC address, ano yung destination MAC address, ano yung IP address. Again, optional to, ano yung mga gusto mong i-validate. Source MAC address lang ba? Pati ba destination MAC address? And even the IP address. Ayan. So, may include dito, yung list. Ayan, So, IP ARP inspection, validate, source MAC address, destination MAC address, IP. So, lahat dinagay niya. Not only one. Inilagay niya 3 parameters. So, mitigate STP attacks. Recall the network that network attackers can manipulate STP o yung spanning tree protocol natin to conduct an attack by spoofing and the root bridge and changing the topology of a network. So, to mitigate STP attacks, use portfast and bridge protocol data unit or BPDU guard. So, ano yung portfast? Portfast immediately brings a port to the forwarding state from a blocking state. Binabypass niya yung listening state and learning states ng ating switch o ng port. And then, it apply to all end users access ports. Yung BPDU guard naman, immediately, error disables a port that receives BPDU. Kagaya ni portfast, si BPDU guard should only be configured dun sa mga interfaces attached dun sa mga end devices natin. So, sino yung mga yon? Ito yung kanina, yung mga end devices. Sana yun? Yan, yung mga access port natin. Diyan natin kino-configure yung ating BPDU guard and portfast. So, portfast bypass the STP listening and learning states to minimize the time that access ports must wait for STP convergence or converge. So, only enable portfast on access ports and portfast on inter-switch links can create a spanning tree loop. Ito yung iniiwasan natin, di ba? Pag nagkakaroon ng loop dun sa spanning tree natin. So, you can enable portfast by using the spanning tree. Ayan, portfast. Dun sa dapat naka-switch port mode access. Yung port na yon. Ibig sabihin, ito yung connected dun sa computer sa labas. So, if you don't want to use that, you can use the default, yung global configuration mode to enable portfast sa lahat ng access port. Ayan, ibig sabihin lahat, from 01 to 24 by default kasi access nakatrunk. So, walang mangyayari, If selected ports lang, gumamit ka ng interface yung range, ng lahat ng mga list of ports na gusto mong applyan ng portfast. Ayan, to verify whether portfast is enabled globally, you can use either the show running config begin span o yung show spanning tree summary. Ayan, makikita natin doon. Ayan, so for BPDU guard, parang portfast lang din. We use the spanning tree, tapos instead of portfast, we use BPDU guard, tapos enable. Ayan. So we have here the BPDU guard can be enabled. Use the spanning tree BPDU guard enable on an interface. So if you want to use it globally, ayan, gawin mo, use the spanning tree portfast BPDU guard default. Tapos ayan, naka-enable sila dito. Yung summary, makikita natin lahat ng mga naka-enable and disable. So, on this chapter, we have a module practice and quiz. So if you want to try them, you can visit yung ating NetAcad. And then for our packet tracer activity, meron ulit tayong packet tracer activity for this one. Pakisagutan na lang din. And that is another requirement doon sa ating list of packet tracer to be submitted bago yung final exam natin. Ayan. So there are 3 packet tracer activities on this chapter. So what did I learn on this module? We learned about by default their 2 switch ports are set to dynamic auto. Naka-trunking sila. Hindi sila naka-access. And then all ports or switch ports interfaces should be secured before natin i-deploy yung mga switch sa production use. And then the simplest and most effective method to prevent MAC address table overflow is yung enable natin yung port security. And then we'll learn about the 3 ways on how to configure yung MAC address security natin. Yung manually configured, dynamically learned, and dynamically learned sticky. So if the MAC address of the device attached to the port differs from the list of secure addresses, so merong violation na nag-occur. So pwede natin palitan, it's either shutdown, ayan yung kanina na in example natin. So by default na naka-shutdown yung violation mode. So we also talk about the goal of DHCP starvation. This attack is to create a denial of service for connecting clients dun sa spoofing attack natin. And then yung DHCP snooping determines whether DHCP messages are from administratively configured trusted or untrusted sources. Basta tandaan nyo, yung mga access ports natin, yung sa labas ng switch, itong mga to, dapat sila yung untrusted. So, meron ka isang switch dito, yung switch na connected sa ibang switch or router, so dapat ito yung gagawin mong trusted. Siyempre, ibang network na to Ito sa labas. We don't know kung sino-sino yung mga naka-plug dyan. So, another good security practice is, or best practice, is to disable yung mga unused port. Yan yung gagawin natin. And then, we can mitigate spanning tree attack by using port fast and BPDU guard. So, with that ends our chapter 11. So, again, we will have our quiz on the Tuesday. Yung coverage niya is chapter 9 and 10. And then, mag-meet din tayo sa Tuesday. Tingnan natin and i-discuss natin by Tuesday after our quiz. And we only have 1 chapter remaining para sa final term. Okay, so with that, thank you guys and keep safe always.